Hi there, and welcome to Minds Makes. I'm Steven Sullivan. This is a channel focused around additive and advanced manufacturing. Our projects and research take place at the Colorado School of Mines, a university in scenic Golden, Colorado. In this video, we will design and 3D print a modular camera mounting system to help us film future projects. We created our CAD files, which are three-dimensional drawings, in a program called Autodesk Fusion 360. We began with a two-dimensional sketch of the camera mounting system. One nice thing about the Fusion software is that Kelly and I were able to open each other's files in the cloud and build off of each other's designs. The camera mount makes use of bearings to allow the camera to swivel and remain level with the ground. We bought the metal bearings separately and took their measurements. Here we added matching cutouts into our 3D design. Once we have the parts printed, we'll be able to press fit the bearings into our camera mount assembly. So now we've laid out the basic shape of what we're calling the camera cage. From here, we added recesses for nuts and through holes for bolts to really make our camera mount modular so we could attach more accessories later. In the previous video on our channel, we 3D scanned our Nikon camera. We were able to import that 3D scan here to our camera mount build. This was very helpful for making sure we got the size of everything right and that the camera would sit comfortably within our camera cage. The first attachments we made for our camera mount were the handles. We also designed a grip to slide onto the handles to be 3D printed in a softer, more flexible material for comfort. We left only a slight amount of room between the handle and grip for tolerance, so the grips would press fit nicely into place during assembly. To further enhance the grips, we took our school logo and patterned it around the edges in a raised texture. Fun little details like this won't require much additional build time or material usage in the 3D printing stage. It's much easier to add geometric complexity in an additive manufacturing process than to do so in a conventional subtractive manufacturing process. So now we can see how our entire design is going to come together and we're ready to 3D print. Here we put our 3D model of the handle grip inside of a slicing software. This software is called Cura, and it works for a number of 3D printers. A slicing software separates or slices the 3D geometry into a number of layers. We can see what each layer of our handle grip will look like here. The slicing software creates a series of machine movements called G-code. The 3D printer will read these digital instructions to build each layer of our part. We can visualize what the movements of our material extruder will look like, starting at the bottom layer and working upward. 3D printers can save material by printing an infill pattern instead of making the part completely solid. The slicing software allowed us to choose from different pattern shapes and densities. And here's our grip being printed in a soft PLA material on a Lulzbot Mini printer. We used Markforged 3D printers to create the rest of our camera mount parts. Markforged printers use their own proprietary slicing software called Eiger. The first thing we imported into Eiger was the lower half of our camera cage. In the settings area on the right side of the screen, we could change several parameters like the layer height, infill percentage, and the density of the part's outer shell. Thicker layers would result in a faster build time, but the printed geometry would be less precise to our 3D model. A higher infill percentage and thicker walls would increase the strength of the part, but also increase the material used and build time. Once we saved this part in Eiger, we had to take the additional step of placing it within a build. A build is where we can organize multiple parts to be printed all at once. By clicking Add Parts on the right side of the screen, we can drop in other parts we had saved in Eiger, or add multiples of the same part. Parts can be repositioned in the build space by clicking and dragging. Once our build was ready, we clicked Print in the bottom right section of the screen. We had the option of printing immediately or saving our build to the queue. If you're already in lab and have your printer prepared, Print Now is a good choice. It's easy to add your build to a queue and start it from the machine when you're ready. The Eiger software is connected to the printers through the cloud and will let you monitor build progress as well as the material remaining in each printer. So I cleared the previous build from the removable build plate and applied a layer of glue stick to the tray. The tray fit back into the machine onto magnetic connection points. I had previously added my build to the Cura and Eiger, so I located the build on the machine's touchscreen and hit the start button. It's always a good idea to watch the first layer of your print to make sure everything adheres to your bed nicely. When failures happen, a lot of the time they happen on that very first layer. This particular build had 300 layers and took about 15 hours to complete. Once the build finished, I removed the build tray from the machine and started removing the parts from the build tray. It's important to be patient with this stage of the process, as the scraper tool is very sharp and easy to injure yourself with. Here I steadied the build tray up against a nearby shelf so I could keep my left hand away from the path of the scraper blade. Depending on the shape of your part, you may be able to just reach down and grab it off the build tray. Adding a chamfered edge to the bottom surface of a part in the design stage really pays off later if you want your part to be easy to remove. It took us a few builds to produce all our parts, but finally Kelly was able to get to work attaching the pieces of our camera mount together. And here's our fully assembled camera mount. You can see Kelly testing out the vertical stabilization the bearings provide. The great thing about the way that we built this is that we still have our 3D design, and it will be easy to design attachments for a boom microphone, external lights, and other accessories in the future.